Assalamualaikum. My name is Muhammad Hazwan bin Muhammad Nazri. I am from Group 5 and there is my two other members. First, Muhammad Firdaus bin Ali and Alif Zaki bin Kamaruzaman. So, in this video, we are going to make a milestone 3 about accumulator-based vending machine in quarters. For your information, a vending machine simulator is constructed on a CPLD and circuit board. So as you can see in this picture, we need to have these things or this module to be in our quarters. So first we need to have adder, accumulator, night rider light, prescaler, operator, binary to BCD converter, input filter and selector. So in this video, I will explain about it. As you can see in this picture, this is about a block diagram of vending machine. First thing, we are going to make 4-bit ripple adder. So in 4-bit ripple adder, we have a half adder. So this is the schematic circuit of the half adder. And the second one, this is the second of the schematic of the full adder. And the last one is the schematic circuit of 4-bit ripple adder. So this is the step how we build a 4-bit ripple adder. Second, we are going to make an accumulator. So as you can see here, this is the schematic circuit for the accumulator. So in accumulator, you see we have the register cell here. So inside register cell, there is another circuit. So this is the circuit for the register cell. And you can see that in register cell we have D flip-flop, AND gate and NOT gate. And then this is the compilation report for the register cell and accumulator. And third, we are going to make a night rider light. So this is the schematic circuit connection for the night rider light. So the first one, you can see we have a counter, and we also have BCD to 7-segment decoder, and we also have mapper. So this is the connection for the night rider light. And then you can see this is the compilation report for the night rider light. So this is successful. And then we have the waveform of the night rider light, and this is also the symbol for the night rider light. And fourth, we have prescaler. So this is the circuit for the prescaler, and this is the compilation report of the prescaler, and lastly, this is the symbol of the prescaler. For the fifth is we are going to make a 4-bit comparator. So this is the circuit for the 4-bit comparator. And for the compilation report, this is for the compilation report for the 4-bit comparator. And 6, we are going to make binary to BCD converter. And as you can see in the schematic circuit, so in binary to BCD converter, we have NIC 7447, a BCD to 7-segment decoder, and a conditional add by 3 module. So this is the circuit that I've mentioned that. So in conditional add by 3 module, there is a circuit. So this is the circuit for the conditional add by 3 module, and then we are going to compile it to prove it is successful. And then we are going to compile for the all module that is binary to BCD converter, and then we can get the waveform for the BCD converter. And last, a symbol for binary to BCD converter. 7, we are going to make input filter. So as you can see here, this is the schematic circuit for the input filter. So in the circuit we have D flip-flop, NOT gate and AND gate. And this is the compilation report for the input filter. And this is also the waveform for the input filter and the symbol for the input filter. So this is the part for the selector. So for the selector we have 3 bus multiplexer, and for the input we have already put it. So let me run first. So for the compilation report is success for the selector, and then we need to see the waveform. So run it. So this is the waveform output for the selector. And lastly, this is the complete circuit for the vending machine with pin planner. So as you can see here, this is the complete circuit for our milestone. And then we have the compilation report for the vending machine, and we also have the waveform for the vending machine. And lastly, we are going to programming the EPM 240 board, and so this show the assignment of pin for the inputs and output of the circuit. And then after the inputs and output were assigned a pin on the CPLD board, the final design was uploaded and programmed into the board using the programmer tool in Quartus. And lastly, this is the demonstration for our project. And as you can see here, we have 2 videos. First video for 50 cents and second video for 20 cents. If the display showed after 1.1 ringgit, so the LED will be patterned just like in this video. So that's it for our group. Thank you.